Hello everyone, and welcome back. So now we're on to the second group problem. So depending on how it went last time, you might want to grab someone different. Or maybe you keep them around, who knows? Maybe they did it easy. Either way, make sure that you are optimizing your team for these problems. You want to have the best team possible. I have my A team with me, various snacks, my traveling gnome, and my calculator. We've been together through much. So what's going on here? Well, what you see is that we have block A and it's attached to a pulley. And you're like, oh my, yes, this is one of those relative position equations where they're going to be all connected together. Now it's got a weight of 60 pounds and block B has a weight of 40 pounds. Now the coefficient of kinetic friction between the blocks and the incline is 0.1. And we can neglect the mass of the cord and the pulleys. What we want to know is the speed of block A after block B moves 2 feet up the plane. 2 feet of the plane starting from rest. Woo! This is going to be a hard one. So I want you to try your best, but if you can't do it, don't worry. But here's your plan. Define the kinematic relations between the blocks. You have to figure out how they're connected. And then draw a free body diagram of each block. After that, apply the principles of work and energy to the system blocks. And the question you might ask yourself is, why choose this method? Why not just go full kinematics on this? Or get our equations of motion? Well, I'll let you decide. We'll talk about it in a few. So, 3, 2, 1, and you're back. So let's try it out. First off, we have to develop a kinematic relationship. Now we have this distance B right here, and we have 2 times the distance of A to get our full chord length. So from that, we can see that the velocity of B is going to be equal to twice the velocity of A, just in a negative direction, because B is moving up the ramp and A is moving down. And we're defining both of their motions as being positive downwards. That's why our velocity of B is a negative velocity of A. Okay, now let's get a free body diagram going. So both of them are going to be feeling friction. Friction does not like motion. It is always resisting the motion. B is moving up the hill, so the friction is pointing down the hill. A is moving down the hill, so friction is pointing up the hill. It's very contrary. It just doesn't like that. Now we're also going to have a tension, which is pulling us back. And why it's twice 2t for block A is because they had that pulley like this. When we cut it, there was 2 times the tension pulling back. So with that, we can there we go. Pen was malfunctioning for a second there. With that, we can start writing some equations. So first, let's do some forces in the y direction. And what we should realize is, well, there's no forces and there's no motion in the y direction. So some of the forces should be 0. And luckily for us, we know what the weight is, so we can actually solve for that normal force. And it's the same case for block B. Now, there's a free body diagram for each of these. They don't have to have the same coordinate system. Okay, we just want to solve for these forces right now. Now, using what we've learned, we can start applying the principle of work and energy to the system, because the blocks start from rest. Now, here's where it probably went crazy for you. You have to remember that this is the sum of all of our kinetic energy, this is the sum of all of our work, and this is the ending sum of all of our kinetic energy. We had 2 objects in here, and so we have the kinetic energy of both and the work being applied to both. Kinetic energy of both and the work being applied to both. We know that initially their velocities are the same. So all of that right there is going to go to 0. That's pretty nice. We also know how far SA has moved, and therefore how far SB will move. We know how to get velocity in terms of VB in terms of VA. We also have equations for the normal force in terms of the weight. So if we plug in everything we know, we look around and all that's left is tension and our velocity. tension and velocity. So, with this, we can then solve. We get that our velocity is going to be 0.771 feet per second. And if you're wondering why we were able to suddenly solve that, because there's definitely, a t here and a t there, it's simply because the force, the work being done due to the cable tension actually cancels each other out. If you look at it, you got a negative 2t right here, we have a negative 2t right there, and they're going to cancel each other out. Sorry, negative 2 times negative t makes it positive t. So we kind of got lucky there. It's really nice that the tensions cancel each other out, so we don't have to worry about the tension. So with that in mind, thank you for listening, and I'll see you all next time. Bye-bye.